We're looking at number 5 in your notes. It's up there on the screen as well. If you would, check it out. I want to give you a little direction, then I'm going to have you guys try to do this on your own. Beyond that, so this says, find a polynomial that represents the area of the parallelogram. You can see an illustration of that parallelogram right there. So the one question I think we should probably ask to be able to complete this is, how do we do this? Like, what is the area formula for a parallelogram? Does anybody know how you find the area? Any ideas?
Base times height.
Base times height, yes. So area for a parallelogram is equal to the base times the height. So armed with that information, if you guys would, please find a polynomial that represents the area of that parallelogram. Right there, the height is labeled 2b minus 5 inches, and the base is labeled b inches. Take a minute, work that one through. And if you were successful with the video, this should go pretty well. Give it a try. Guys, let's look at a solution for this one. It says area equals base times height. So I'm going to fill in the expressions for base and height. Now check this out. Peeking over shoulders, saw some good answers. There's some things I think we need to review and relearn a little bit. So the base is, would you guys agree that the base is clearly labeled with the letter B? So we're just going to say base is B. Now, the first thing that I saw missing from some of your papers as I was looking over things is missing parentheses. Did you notice the height is not 2b? The height is not minus 5. It's the whole thing, isn't it? Yeah. The height is 2b minus 5. Like the entire expression is representing the height. So when I put in the height, I'm not going to do this. This would be a major mistake. I'm going to do this. This would be correct. I'm going to put it in parentheses. Those parentheses are grouping symbols, grouping those two terms together, saying that this whole thing is the height. Not just the first term, not just the second term, but the whole thing. Okay, so as we write it like that, there's only one step left to go here. And this is from the video. When I've got a binomial, which is this right here, times a monomial, or a monomial times a binomial, what property do we use to simplify? Distributive, yeah, you don't have to whisper it, you're right, distributive property. And so this b gets distributed, multiplied, is what the distributive property is. It's multiplied times both terms on the inside. So what is b, not plus, but b times 2b? 2b squared. 2b squared is correct. I saw a couple of folks had 3b. If you've got 3b there, that tells me that you did b plus 2b, right? Because b plus 2b is definitely 3b. That's not what this is. This is b times 2b. So it's 2b squared. Minus 5 times b is 5b. So this right here would be the correct expression for the area of that polynomial.
Sorry, not supposed to.
For the record, Will almost fell down right there.
Sorry, Mr. Anderson.
Yes, ma'am.
Scissors.
That's what the whole video was about. That's what this was about too, wasn't it? So what we're going to do next, you can see coming up here, we're going to be multiplying a binomial times a binomial, and that's going to require a slightly different thought process. And so I'm wondering if you guys have heard of this, FOIL.
Yes.
Maybe in a pre-algebra class, maybe an algebra class in the past. Have you heard of FOIL? It's a pretty common thing. Yes? Raise your hand if you have. Hey, raise your hand if you have. Sam, Alec, have you heard of FOIL? Raise your hand. Alec, Sam? No? Alec has, Sam hasn't. Okay, cool. Okay. So guys, this is fundamental. This would be one of those things like if you pass an algebra class and you don't know what FOIL is or how to use FOIL, I would say that you should not have passed the algebra class. So fundamental, right? This is basic foundational stuff. As you move forward into algebra, you need to know how to do this for sure. Okay, so let's kind of get a basic lay of the land here. Do you guys see how this right here is a binomial? And that right there is also a binomial. Let's put B for binomial. They're both binomials, and we're multiplying them together. We are not adding them together. If we were adding them together, there'd be a plus sign in between. And please remember that whenever you see two parentheses kind of butted up against each other like that, that implies that it's a multiplication problem instead of an addition or subtraction or division. So that means multiplication. So foiling is multiplication. And let's talk about what FOIL means. FOIL is an acronym, which means it's a word that stands for other words, right? 4 other words. So let's see if you guys know this. I'll just do this off to the side here. What does the F stand for?
First.
F stands for firsts. Okay, so that means we're gonna multiply the first terms together. Okay, what about the O?
And outside.
Yep, I usually say outers, but outside works too. So you get your firsts and your outers. So we're going to multiply the ones on the outside together. And then the I stands for inside or inners. Yep. And then L stands for last. Is correct. Okay, so let me give you an example of this, and then I'll give you guys a few opportunities to try this on your own. If we multiply the firsts together, that means we are multiplying 6a times a. Do you see how those are the firsts within the binomials? So what is 6a times a? 6a squared is right. Remember, foiling, just like the distributive property, is multiplication. And really, to be honest with you, foiling is just sort of like an advanced version of the distributive property. That's really all it is. If anybody who's ever interested in understanding why FOIL works, I'd be happy to show you. Okay, and then O stands for outers. And so that would be this orange arc representing that. So O standing for outers, that would be 6a times 3. What's 6a times 3? 18a is correct. Okay, so far I've done FO. We need to add FOIL. We need to add the eel part. Okay, so I need to do the inners now. So the inners are going to be these two. Those are the ones that are on the inside of the full group here. So negative 7 times a would be? Negative 7 times a, just negative 7a. All right, and then so far we've done FOI. We just need to add the ol onto it. So L stands for lasts. That would be negative 7 times positive 3, negative 21. So this is color-coded. You can see that up there. You can see how the blue arc goes with the blue term, the orange arc with the orange term. And can you see that this is, this is firsts, outers, inners, and then lasts. Can you see FOIL within those arcs too? Hopefully all the color coding makes sense. So at this point you've done FOIL. A lot of times, it won't be true of every single time, but a lot of times you'll end up with some terms in the middle that can be combined. And can you see that here? You see how the positive 18a and the negative 7a are actually like terms? So when you add those up, what do you get? 6a squared
plus 11a.
You got it, plus 11a minus 21. Okay? So that's FOIL. That make sense? Okay. Let's do a quick review here. Are you done with those?
Oh, yeah, sorry.
Okay. Quick review here. What would you name this polynomial?
Trinomial.
Trinomial degree?
2.
Cole, what's the lead coefficient?
6.
Got it. Okay, cool. So if you guys would, take a look at number 7. Number 7, I don't know, it's a little... No, let me decide if I want to do number 7. Hang on. Let me look ahead. 7's not too much different, but it's a little different. I want to do 7. Why don't you guys look at 7? See how you do with this one, then we'll do a little practicing at the board, okay? Try number 7. Do you see how it's a binomial times a binomial? Hopefully we can then use FOIL to multiply. Good first thing for us to notice is that we've got a binomial times a binomial. I've got 2 terms times, not plus, times 2 other terms. And so we're going to use FOIL. Whenever we're multiplying 2 binomials together, we're going to use FOIL. So I'm going to multiply my firsts, and I'm actually going to give myself a little bit more room here. Sorry. There we go. Okay, so if I multiply my firsts together, that would be 7m squared times m squared. And those are like bases, right? It's m squared times m squared in there with the variables. So if you are multiplying like bases, what do you do with your exponents? Add them. Yeah, 2 plus 2, of course, is 4. So when you multiply your firsts together, you should have gotten 7m to the 4th. Then Now that we've done the F in FOIL, we are going to do the O. The O would be your outers. So this was one, as I walked around, a lot of you had some good questions on this one. Notice that the bases are not like. It's m squared and it's n, so there's not going to be a lot of simplifying we can do here. I do see a positive times a negative, so that would be -7, and then m squared times n is just m squared times n. There's really no combining down you can get there. It's just a multiplication problem. So that's your O, that's your outers. Next, of course, is your inners, so that would be these two right here, -4n times m squared. And this is a lot like your outers. So -4n times m squared would just be -4n m squared. Again, positive times a negative is a negative. And then lastly, your lasts would be -4n times -n. Negative times a negative is a positive, so this will be plus. And then n times n, those are like bases, right? So what is n times n? N squared, right? So it'd be plus 4n squared. Okay, so you can see the F, the O, the I, the L, hopefully color-coded out there for you. If you notice here in number 6, the two middle terms did combine. We add them up. You see how in this one the two middle terms do not do that? See how they're different? They're not like terms. So there's nothing additionally we can do with this. We'd have to leave this alone, and we're done. You guys have any questions? How'd this go?
Aren't they the same though, like in the middle? Like n squared times.
Oh, shoot. You know what? I wrote it in... Hey, hold up. I wrote it in a weird order, and I just played tricks on my eyes. That's just like an honest mistake on my part. Those middle terms are like terms, aren't they? Sorry. I wrote them backwards, and I played tricks on my eyes. You see how they both have an m squared and an n?
Yeah.
So they are like terms. Sorry.
Once you put the variables in alphabetical order.
Yes, you're supposed to do that. I didn't do that, and that's probably why I didn't see
do
it.
it either.
Yeah. Okay, so let's fix that. Hey guys, listen up. Hey, so when you do combine those, because they are actually like terms, when you combine those two middle terms, two terms together, what do you get? -11 m squared n. I'll just write the order like that. Shh. I heard a wait. Wouldn't you do something? Say again, Paige?
Would it be to the fourth power or would it say?
No, remember when you add like terms, you leave the variables exactly the same, and you add the coefficients. This is where it's really, you got to really take your time and keep the parts of these expressions straight. If you are multiplying like bases, you do add your exponents. But if you are adding like terms, you don't do anything with the variables or exponents, you only combine the coefficients. Okay. All right, so let's do this again really quick. Trinomial, obviously, what's the degree on this one? The degree is 4, yep. And what's the lead coefficient? 7. Yep, you got it. All right. Let's see here. This is going to work out good. Let's go ahead and move forward here. We'll do a little more practicing with FOIL in the coming days, and maybe here at the end as well. We're going to look at a couple of other scenarios. Let me build this up. Hey guys, focus right here. In the video and as a warm-up today, didn't we multiply a monomial times a binomial? Yeah. And what did we just get done doing? Binomial times a binomial. What do you see right there in number 8? Can you see the pattern? We just keep adding a little term into each of these and seeing what happens. So there's no cute word like FOIL for something like this. We're just going to do kind of the advanced version of the distributive property to help us with this. So I wanted to take you guys through this one. I think you'll see one or maybe two of these in your WebAssign when your WebAssign comes up for this section. And we'll practice this again tomorrow for sure. I think tomorrow we'll practice with a FOIL and maybe one of these, something like that. So here we go. Whenever you've got a binomial times a trinomial, we're just going to use kind of an advanced version of the distributive property. Here's what it looks like. I'm going to take this term right here, which is 3x, and I'm going to multiply that 3x times all the terms in the trinomial. So maybe it would look like this. Multiply here, multiply here, multiply here. And I would suggest drawing in those little arcs to kind of help you keep track of what's being multiplied times what. And to give you a brief preview, after we're done with that, we will distribute the -1 throughout as well. This is a little more advanced version. If you had an Algebra 1 course last year, you may or may not have done something like this. If you had a really good, solid program, maybe you did. If it was kind of the light version, maybe you didn't. We're going to do it here. Okay, so let's see if we can go through this together term by term, making sure we keep everything straight. Victoria, what is 3x times 2x squared?
6x to the power of 3.
Okay, hope you guys agree with her. Definitely correct. Let me give myself a little bit more room here. So 6x to the third. Okay, so we just did this one. Okay, so now we're going to do the next one. Grace, what is 3x times -5x?
-15x
Close.
squared.
X times x is x squared. Yep. Guys hanging in okay? Okay. We're going to do this next one. Luke, what is 3x times -3? It would just be -9x. Agreed. Okay, so at this point, we're about halfway done. We have taken that 3x and we've multiplied it throughout the trinomial. And now our other task is to take the -1 and do the same thing essentially. So I'll highlight this in red. We got -1. We're going to multiply that throughout those right there. Okay, so what's -1, Will, times 2x squared? Agreed. Okay, so -2x squared goes right there, so we just did this one. And then we've got -1 times -5x. Carissa, what is that?
5x.
Yeah, positive 5x, right? So we're going to put plus 5x. Agreed. And then Joel, how about the last one? -1 times -3.
3.
So we put plus 3. Nice job. Okay, so at this point we've done all the multiplying we're going to do. I want to make sure you understand. Do you guys see how this is really just a distributor property? We're just distributing the 3x and then distributing the -1. And of course, you look at this, you can see what's left over here. Aren't there a bunch of like terms? Okay, sorry. So what is like 6x cubed? I don't see any -2x cubes anywhere. I'm looking at this 6x cubed.
Oh, cubed.
Yeah. You guys see anything like that? I don't either. So since there's nothing like that term, I'm just going to go ahead and write that in my answer line, and I'll keep going. So that one's done. What do you guys see up there that is like -15x squared? -2x squared. There you go. So when you combine those together, let's think really carefully. Garrett, if I do add those up, what do I get?
You get -17x squared.
Nice job. Notice that he did not add the exponents. I'm not going to be adding any exponents here because we're adding instead of multiplying. Okay, and Haley, what is like -9x? That's the next one up here.
5x.
The 5x is, so when you add those two together, what do you get?
-4x.
That's exactly right. Okay, and then Hosanna, what's like the 3?
What?
What's like this 3?
Nothing.
So what do we do with it?
Just plug it in.
Yeah, just put it in the answer line, right? Nice job. Okay, so that right there would be our answer for this one. 6x cubed minus 17x squared minus 4x plus 3. Okay, you guys have any questions about that? Okay, let's do this again. If we're going to name this polynomial, what would you call it?
Special.
Yeah, no special name. You just call it a polynomial, right? If you called it a quadnomial, I'm sure I would know what you're talking about, but technically it's just a polynomial. What is the degree for this one?
3.
Do you see how easy it is to see the degree when you go in descending order of degree? It's not necessary at this point, but it is a very handy skill. And what's the lead coefficient? 6. That's right. Okay. You guys ready to wrap this up? Okay. So I think we got one more to go here. We might get just a little bit of extra practice here at the end. All right. So check this one out. Oh my gosh. We're just like getting all over the place here. So this is, you might have thought that this was going to be a trinomial times a trinomial. That would have fit the pattern pretty well. That's not what this is though, is it? So if I were to erase if I were to erase that first factor, what is this? It's a what? Binomial times a binomial. And what would you use on just that part? Foil. Would you do foil? Remember, binomial times binomial means foil. Okay, so then if I let that be there again, do you guys see how this is essentially a foil right here with one additional step at the end? And we'll deal with that additional step. I think we'll deal with the negative 3x at the very end. I'll kind of go out of order as it's presented. So I'm going to do a FOIL first. And I'll remember that that negative 3x is there. I'm not going to forget about it, but I'll save that for the very end. So this is a good opportunity for you guys to re-practice what we did earlier. Would you take just a minute here, see if you guys can FOIL those binomials together, and we'll talk about the negative 3x. So just ignore the negative 3x for now. Just FOIL the two binomials. The distributive property now. So I'm going to distribute that negative 3x throughout. So let's see here. This will be our final challenge for the day. Negative 3x, Ashlyn, times 2x squared. What's that?
Negative 6x cubed.
Agreed. Nice job. Any questions there? Okay. So then, Cole, we're going to do negative 3x times negative 9x.
27x squared.
That's positive, right?
Yeah.
Nice work. And then, Lana, our last one up there is negative 3x times negative 5. What's that?
15x.
Nice job. So plus 15x goes there. That would be our answer. Do you see it's kind of a two-stage process there? Got to do FOIL, then distributive property. Okay. Let's name it. What is it? Trinomial. Degree?
3.
Lead coefficient? Negative 6. Guys have any final questions before we close this up for the day? All right, so when you come to class tomorrow, we'll practice foiling again and something like this again, and then we'll be moving on. There shouldn't be a video for tonight. Just have some homework, some web assignment for tonight. So hope you guys have a good day. Look forward to seeing you tomorrow.